Thank you very much. And it's my great honor to be able to introduce next speaker, Professor Shin-ichi Tanabe from Waseda University. Now he is the president of Architectural Institute of Japan and also the academic council member in Japan. 田辺先生、お願いします。
So thank you very much for a very kind introduction. Today I talk. Wait a minute. Okay. Today it's I'm talking for the personal environment comfort system for in a zero energy building. It's a real instrument mounted in the real building. Okay. This is the target building. So completed 2020. So this is the company T Innovation Center. And it was located in Tsukuba City, Ibaraki, and also two-story building. And for second floor for activity-based working, it means so people can choose the working place in your office, not fixed desk. And office building is floor area is 4,750 square meter. So around 100 people it's working there for mainly for the research people. And for energy system for groundwater heat exchange and wood biomass heat and the power supply system and PV panel for 200 kilowatt. And also this building, so they cannot sell the electricity to the grid because of some restriction. So that's why we put the battery power storage and the 4,600 kilowatt hour for the battery. Today it's energy side, it's not so much I'm talk, but ASHRAE 90.1 baseline is something like that. But for the propose, when we design, and the amount of energy is like 48.5% compared with ASHRAE 9.1. And then we use a PV solar cell and also biomass CHP. It's net zero plan. But actually, this building is really net zero and during 2021, and also for zero emission building, because we have a biomass CHP. So this is completed. This is the inside view in the office because we try to keep people more comfort and healthy. So that's why we introduce 3 types of the PECs in real office. One is a ceiling mounted PECS. Sorry, some line is ceiling line is deleted here. But we have ceiling radiant panel, and the air is blown to the plenum. And then we have ceiling mounted PECS with a fan coil. And also for human position detection sensor and thermocouple measure the heat flow from floor. And also for another PECS, the partition type, I can talk in later as more in detail. And this type PECs, so 3 types of the PECs we install in the building. This is an example of a ceiling install PECS. This is outlet, so some coils, and also we have AC DC fan to blow the air to the person. So this is sorry for that. It's some electric bulb, and also DC fan is very low energy power required, 3.1 watt, and the coil and air volume is 236 cubic meter per hour. This is maximum, so you can control also for airflow. Cooling capacity is 470 watts, so it's the maximum point. And we make application with the smartphone. First one is not very well function because it takes a long time to when you turn on. So turn on the PECS, it takes some time. So that's why we also improved the application from the smartphone. You can change very quick response. And this is a partition type PECS. So this is a recirculated air. The air is from the under the desk and then going to the outlet for the partition. So air volume adjusted to the upper part. So you can also get the heating and the cooling from this partition type PECS. And air volume adjustment is like a manual, and also so you can use app also. But some people prefer just adjustment yourself. And the DC fan is only 6.6 watt. It's very small. And the coil is inside. And outlet air volume is 130 cubic meter per hour. A cooling capacity is 150 watt. So this is the maximum capacity, of course. And this is a more simple one for desk type of PECS. We put a coil below the desk. This is outlet. And also for, you can adjust to the angle to your, some people don't want to blow to your, this part of the body. So that's why, so you can change. And the fan is only 1.9 watt. And the cooling coil and the outlet air volume is 50 cubic meter per hour. This is the maximum one. So cooling capacity is 70 watt. And also air direction adjustment is possible to manual. And also this one is possible to on and off and the change setting with the app by smartphone. So, and we operated 1 year. This time, I'm simply explain so what's going on during the 2021. So this office divided zone A and B and D, C and D. So zone A, we installed the ceiling 57 unit, partition is 30 unit, desk type is 28 unit. Is installed in the DR office. But this part is more constant control over temperature. So even without the PECS, so they can feel very comfort. This is a very stable condition. But zone B and C is more like a relax. Sometimes natural ventilation is introduced this place. And close to the atrium. So it means for the air temperature is wide range. And also D is more like a more flexible zone. Maybe people, relax and something like that for exercise. And today is I only for talking for A and B, just for example. And whole year observation. So season usage rate of PECS. Spring, not so much people use, but summer. So a lot of people use for ceiling PECS, partition, and the desk type is a little bit lower. And fall, of course, it's a small percentage. And winter for desk type PECS is sometimes used in the winter also. So it means for summer, so they prefer more for PECS from this building. And interesting thing is the time they use from a big data. So for the summer, when you come to the office, they start to use from 7, 8, 9 p.m. And then after lunch, they use again for 12, 13, and 14. So it means more use in the morning and after lunch due to the high metabolic rate. Probably if you take a food after the lunch, so maybe they need something like a cooling power for that. And also in the morning, they come from the traffic So walking, it's I think for the PECS study, we have maybe for more focus on the metabolic rate activity yourself. And spring and other type, for example, winter, so it's late of the day, 2 o'clock, 3 o'clock, so they start to use. And I plotted all, because we have a data for the C and D, but the zone A office space, we plotted for the ASHRAE comfort chart. So all dot is without the PCES. So office zone A is more a fixed type of temperature setting. The people use during the summertime, even temperature is 26 or something, so they start to use for the PCS. And zone B is a more relaxed place because the temperature is wide range, because not control very accurate. So it seems during winter, so they use for heating, because very nice to walking. It's very wide space, and probably they feel a little bit cold, and then it's they start to the PCAS system. So buffer office space we call, they use the PCS to compensate the summer sensation. And also during this year, 1 week, 2 weeks, we prohibit to use PEC system. So because they used to use, then we prohibit, don't use, and we stop the function, and we ask them to the percentage of satisfied. Green one is with PECS. So they're satisfied and neither and slightly dissatisfied, but we prohibit the drop satisfaction level is very high. So they like it. So once maybe use the PEC system, this kind of office, so probably they control yourself, because person to person metabolic rate and the preference is different. I think it's this PECS function very well. So we have yearly alarm data, not only 21, 22, so daily operation. So that's for us, it's very interesting to the effect of the PECS system. The conclusion, so T Innovation Center opened in January 2020. In office units, zero net energy and emission were achieved during 21. 3 types of the PCCS are installed in the different area. The system specification as described. So usage of PCS are investigated. During summer, usage rate of PCS are higher, and during winter, they use this type PCS for warming. They use the PCS more in the morning and afternoon lunch due to the high metabolic rate. In office space A, they use the PCS in the morning and lunch, the buffer zone space. So they use the PCS for compensate summer comfort. So we prohibited to use for PCS system during a certain period. A percentage of dissatisfied significantly increased without the PCS. Okay, this is my conclusion, and this is a big project. So I'm thank you to all the company and the university collaborator. Thank you very much.
Thank you very much. Now we have 30 minutes for discussion, and I'd like to start for the question, especially for Professor Oresen and Professor Shin-ichi Tanabe. If you have a question, please raise your hand.
Yeah, I wanted to know in the building, did you have like a general system, and what was the set point used for this general system?
So usually for this kind of, they use radiant cooling and heating system, and in some places it's something like a fan coil unit, so different. And the set point temperature in Japan is very typically 26 degrees. So this is a design temperature in Japan. It's a winter time, it's slightly lower. So 22, 23, but actual operation, our building sanitation code, the measure real office building temperature is around 25, 26, even winter.
Yes, thank you for the interesting presentation. I'm Arnold Janssens from Ghent University. I had two questions. One in relation to the ceiling installed PECS. How were they positioned? How was the position defined? Was it directly related to the desks where people were sitting?
We not normally distributed, so we expected the person to close to the ceiling. But of course, it's desk is also changed position, and they can open or operate nearby your ceiling. So not one by one person. One person.
So
okay.
Well, one person can operate a single PECS.
Yeah. Yes.
Okay.
Yes. Okay, here is the ceiling is 57 units. So,
yeah. And then the second question, the systems you have been discussing are PECS assisting thermal comfort. Do you also have experiences with PECS for indoor air quality?
Yeah, very good question. Actually, for the system, it's only this ceiling system. It's possible to provide fresh air. So partition and this type is only the circulated air. So we asked the IAQ for our survey, but overall, it's space is quite good air quality. So we couldn't find some difference, big difference between the PEC or without. So, this is going, so we have a data for year. So I can show in the later, probably for the other aspect. Yeah, thank you.
Thank you for interesting result. My question is, what's the population size of your panel? How many people participate in a panel?
It's whole employee. It's a little bit less than 100. It's around 100 people.
Have you done any statistical analysis of your result? Because I couldn't see the statistical analysis.
Yeah, yes. Because we ask, this is very particular, the trend of the difference between, so this is the percentage actually. So how many people use? So it means, so of course it's percentage, it's different by person. So we have some analyze for the person by person. This is usage rate for the times week person for each season. So I think for, I don't show the some static analysis, but for spring, summer, fall, probably it's much more easy to get the static analysis, the difference between season. Sorry for that. Yeah, a very simple result I show you. Yeah.
There is another question over there.
Thank you for a very interesting study. It's very precious data that you are getting here. So I have one question is about from air quality point of view, like how much air you actually provide. I mean, I know this study is more about thermal comfort, looks like. Do you have sufficient air so people don't need to worry about the air quality?
Yeah.
Is that case?
Yeah. Typically, it's Japan, we have a building sanitation code. And also building over 3,000 square meter must keep 1,000 ppm CO2. It's a mandatory. So it means for 30 cubic meter per hour, so it looks like 7 liters per second air provide. Actually, this also space is mandatory. provide the outside air. And also, this is my guess, probably this building is control for CO2 demand. So they measure the CO2, and if over 1,000 ppm, they provide more outside air. And in Japan, they're not 100% fresh air. So because the cooling load is high, so some part it's recirculated, but they provide something like this, around 7 liters per second or something like this. I think this room too.
So then compare with, I mean, this is like more, I think the way the PECS systems are installed, from air quality point of view, it's more like a well-mixed system, right? You have air supply from different locations. So that's a well-mixed system. Have you compared with other like a well-mixing typical traditional system that has the same ventilation rate, same level of ventilation rate, whether people have?
Oh, that's a good question. So I haven't such a data,
Okay.
but in the lab we once tested, but yeah.
No. Okay. So can I ask one more question? Just this kind of system in terms of cost, how does this compare to the conventional system cost-wise? Are we talking about a significant increase? Now, the reason I ask this question is that we have also studied the personal heating and cooling. US DOE actually has this APA-E project. We developed a prototype and trying to get company to make them.
Yeah.
But the companies say, well, we don't know whether they're going to make a profit or not because it's so expensive to. So I want to learn what's the situation in Japan. Is that more acceptable?
Very good question. We make a PEC system, but it's sometimes very hard to penetrate in the market. One thing is office building, like rental office space. PEC system is belong to the desk or HVAC system. If we make a partition, this is like a desk. Accounting system is different. Because if you belong to the HVAC system, building commissioning and the building people taking care, desk, maybe other accounting people taking care. And also for the period to use for the desk is maybe 10 years, 15 years, compared with the HVAC system, much smaller. So even for the chair, we have some problem. If you introduce a chair, so chair is belong to the HB building or belong to the non-building accounting system. But this building, the lucky is owner of the building is HVAC company. So that's why they try. So that's why we are lucky to have this kind of data for whole year. Yeah. But it's, of course, it's we have to explain how much productivity and satisfaction is going up. So to the owner and developer or something like this. Yeah, that's most difficult part. Yeah, to penetrate. Vienna, you should come.
Shin-ichi, very interesting study. I have a question because I understand that they control the thermal comfort by using the system. Would the same adjustment be possible if they, let's say, control their closing? And so the point is like this, that we install here a very sophisticated system. People feel too warm, so they provide, we provide them the opportunity to control the thermal comfort by the system that provides the cooling. But what if they were told, you can adjust your closing? So would that be possible to arrive at the same level of satisfaction by adjusting the closing, or would the system be still needed to provide the level of satisfaction?
Yeah, I think it's a very good question. But this time it's just they can switch on and the air volume by yourself. So the closing it by yourself, and it's more adjusted by the person. So if overall the office is nice to have closing crow value to the setting. The one serious problem in Japan in the morning or in the daytime, the man coming out in from outside, this temperature, they sweat, and also they turn down the set point temperature to 22, 23, and the women is freezing in the office. So that's why PECS system, maybe it's some benefit for the diversity, and everybody may be happy. I think so, yeah.
Yes, this is often a discussion, this men and women. So in general, in an office, you should let the women control the thermostat, not the men, because they are the one who addresses according to the season. The thing with clothing, I think building owners give too little information on people what they can do themselves without having a personalized system. And basically with a jacket like this, off and on is like 2.5 degrees. So it's a very fast change of your comfort. Regarding the data you had where people are warm in the morning because they come walking from the metro or driving a car or going on bicycle, we have in the revised Danish standard for ventilation of buildings, we have allowed to design a lower temperature in the morning, lower than the comfort interval for the first hour. So you can use more night cooling. You can kind of undercool the building because we know they are warmer in the beginning, but it's only for the first hour or 1.5. And regarding economy, I don't think we can get if we save some energy, that will not be enough to pay for the extra system. It's only you have to rely on you have higher comfort. We know we have some data, we can calculate that into increased productivity and what that means. And if you do that, then I think you can get a good balance. But that will be the only way. If it's only the cost of the equipment and the operational cost of energy, I don't think you can get a balance.
Have you monitored the preferred temperature? So they were adjusting the system, and then they probably adjusted it and then maintained most of the time during the day. The temperatures were maintained at a certain level. And what was the variability for all the people for those preferred temperatures? Because that would tell us, you know, how big variation you could have.
Yeah. Thank you very much. I think it's big question. Very good question. So we take a day. Yeah.
Okay.
Looking for data.
Sorry.
Thank you.
So the temperatures were monitored, right? For each,
yeah,
at each station.
Yeah.
So.
I still have a question, Bjarne, for you. How is the industry, like you told us the target audience is manufacturers and designers. How are they involved already now in the annex? Or not yet?
Well, there are some, yes, there are some companies in the annex. We don't have we haven't made like a special advisory group or so, but we know some people, they are working in company which are interested in this. And there are several companies who are interested, but how to sell it, how to get to see it's a good investment for the building owner. I still think there is a hurdle to get over. And one of the critical things we saw with the system, we had a system, a Danish company had a system on the market that came on 2008. That was a bad time because all new building construction stopped in 2008. So they were a very bad time they came on. But one of the critical things here was it was very much focused on the air, the ventilation, which I think is really the most important part of a personalized system. That is the fresh air. But how do you get it to each working place? And so it looks nice. I know here in Japan, you have many places underfloor air distribution. This is a perfect case because then you just have to dig down in the floor and get the fresh air. And then you can do some adjustment. To do cooling, we have seen now, we have tried with Peltier element to do cooling at the workplace is very difficult. The only cooling which is efficient is probably increase air velocity by a fan that is not using too much energy. Heating, you can do more efficiently at the workplace.
Yeah. One question, have you asked people, population, if they like the system or not?
Yes, we have data also from all the laboratory data show they like it, and they also increase productivity, but also the one from the field studies. And your data show that also they like it, especially also because they have some kind of personal control. But that's what we see when all the studies have been made, is that the people like it, they have a higher level of comfort.
Sorry.
We never talk to each other at work. We only do that at conferences.
I haven't seen the. I talk with Shin-ichi. We talk all the time at work, Piano. You know that. So, have you considered to run a placebo study on this? So, say everyone will get the PECS, but only half of them will. I mean, everyone can control, but half of them will have an effect of the control. The other ones will not, and whether that would affect their satisfaction.
Interesting, yeah. I think it's this is satisfaction very depend on the self-efficacy. So you can choose or not. That's very important for them. I don't know, maybe placebo they try to do, but no cooling air, bro. Maybe they're angry. I don't know. Yeah.
I think it will be difficult to do a placebo because you feel it immediately.
Very interesting thing is here is a corner, not control very much about the temperature and the humidity things, but they prefer. Sometimes they concentrate in the office space, so they just go out, but they feel something like they need some warm, and they turn on the desk warm and then continue to the work. I think this kind of thing is very nice to have that kind of space, not the very uniform space in office for your creativity or productivity. Yeah.
Thank you. Hilde, correct me if I'm wrong. The discussion is for all the, yes. So then I have a question for Ben Jones, if he's still there. So could you, he left.
It's a pity because there's also an online question for Ben.
I'll ask it to Ian then. Since Jenny Lowe came up with the idea, how confident are we that the effects, the dose response effects, are linear? Because that's the major assumption behind the way it's implemented now.
Ian, can you use a mic? Otherwise, people online will not hear you.
So your question is about if you don't have a linear dose response, how do you figure out, if I introduce so much air and reduce the concentration, say by a half, have I really halved the harm? I assume that's your question. I think the short answer is for many contaminants, we don't really know exactly what that is. Some of it's because those studies haven't been done, or if they have been done, they're not done by engineers, they're done on the medical side of stuff. All we can do is read what they say, right? And so that's what we go with, right? And sometimes it's linear and sometimes isn't. I mean, most contaminants are linear. There are some chemicals that aren't, right? But most chemicals, it's linear.
as far as I know, PM, which comes out the biggest here, according to the global burden of disease study, is not linear.
Sure. And
so why use the linear assumption then?
oh, because you'd have, if you're not, you always want to use depends on the amount of information you've got, right? If you have a lot of certainty about a nonlinear response, then use whatever you're very certain about. But if it's kind of, if the degree of nonlinearity is kind of squishy and changes depending on the study you look at, then you can't legitimize using something more complicated than the data would all agree with. And that's always the challenge with these things, right? Is how certain are we of the shape of the nonlinearity based on the data sets that we have? Because things should be complex enough, but no more complex.
Right. So we're more certain about the linearity than WHO is in their global burden of disease study?
No.
So they say it's nonlinear.
Okay. That's fine with me. What do you want to do?
Use their curve.
That's also fine with me.
Okay, I think you can continue this in Annex 86. There is an online question from Angela Simone for Benjamin, but maybe Constanze, can you answer it? I will try. Sorry to interrupt you. There is a question online for Benjamin, but maybe because you're also author of this study, I will read it. Could a new DALI be adapted for UK and European member states? That's the first part. And is this work part of Annex 86? I think so, yes. When you say that in Italy they are measuring in office buildings, do you mean that it would be possible to use the current DALI methods for identify a metric for office buildings type? And between offices and residential buildings, do you expect the same or other contaminants of concern with the highest DALI loss?
Right. So the way it works is that you identify the pollutants that are of concern and you apply the harm intensity to each of them. So it doesn't matter what type of environment you're assessing. So it could be a different weight of different pollutants depending on the sources.
Yeah. So it's more a framework or a method how to apply. It's more a method how to apply than the result is what.
Right.
Yeah. And could it be adapted for UK and European member states? It was the first question.
For any member.
Yes. Yeah. Okay.
And any country.
Okay, I think then it's clear. If it's not clear, Angela, just add in the chat and then we will ask again. Are there other questions for one of the authors or presenters? Yes, there is one.
Yeah, I have a question for Professor Tanabe. And the personal environmental control system, so when we started this project, which is sponsored by the DOE, the motivation was to save energy. So basically, if you use local heating and cooling, you can change the set point of the building, the larger space, to a higher temperature in the summer and lower temperature in the winter. So we reduce the temperature difference across the envelope, right? So which means the heating and cooling load will be reduced. And then, but if to restore the thermal comfort for people, we have to use the personal environmental control system, right? Is this something, a motivation in your study or some other studies in Japan? Is this something beneficial enough? Because we run a simulation, energy analysis. It does save, you can save up to 30% of energy.
Yeah, I think for example, in the morning in some place at the office, they cool down very much. So if you keep 25, 26, so you can save energy, of course. But now we're talking for the space. For example, like resilient cooling, if the very hot heat wave coming, if in the future, of course, and then your capacity of chiller and boiler must be bigger than before because of the high outside condition. But if you design that kind of system, so a lot of potential load for the chiller, maybe 20%, less than 20% capacity, or you use that. So it means, for example, if you have a 2-story office, so for example, application app, maybe, okay, you can move to the upstairs, and then this floor may be closed. And then it's refrigeration or heating and cooling system. You can design smaller one in the future. That's I'm thinking. It's of course a PEC system can help something, but to keep the comfort, it's nice to office space maybe smaller for some time, very special day. So and then you can design capacity of a refrigeration system and also heating boiler system is much smaller.
There's potential for that.
Yeah, it's a more energy saving potential, I think.
Okay, I want to jump to Annex 78. Pavel, I have a question for you. One of your subtasks, subtask B, is named how to partly substitute ventilation by air cleaning. How are you going to tackle this? And do you have already results? Because I think everyone is interested in it. So how to do?
Well, can I escape as Ben? So and ask maybe someone else can. No, it's basically it is the main aim. One of the main aims of the annex is actually to be able to predict the effect of the gas phase air cleaner in a similar way as we are predicting the requirement for ventilation. So this is why our premise is to look at the same metric that is used to predict the ventilation. The metric that is used to predict ventilation is actually perceived air quality. So by having the effect on the perceived air quality of the gas phase air cleaner, we can then have an equivalent effect from the air cleaner that can substitute or support the existing ventilation, prescribed ventilation.
Basically, what we are talking about is to test the clean air delivery rate of an air cleaner, which you then compare with what are required to be delivered. And this number exactly tells you how much you can substitute. So it's pretty simple if you have the clean air delivery rate. The tricky thing is, how do we test, how do we measure that for the air cleaner?
But once again, I want to repeat that because the prescribed ventilation rates are based on the perception of the air quality, based on perceived air quality. So in order to be able to compare, the effect of the air cleaner with the ventilation, you have to use the same meter or metric to do it. So this is why we use a perceived air quality to evaluate the performance of the air cleaner, because then we can have comparable, effects, and then we can tell what the air cleaner can deliver. On top of the many other advantages, we have to also remember that the air cleaner does not have to only substitute the ventilation and then provide the energy benefit. It can actually provide an additional ventilation to the ventilation that exists. So basically what you can do, you can have a base ventilation that is prescribed by the standards, and then you can have an air cleaner that provides an additional effect to further improve the air quality with very little energy cost.
Okay, thank you. And thanks all the last short one.
Thanks. Actually, more response to what Pavel's comment. I think I have a little bit different, view on that. Is air cleaners? No air cleaners are perfect for all the pollutants we are dealing with. So to me, that air cleaner is really has to be targeted on the pollutants that has high, like a high concentration. When you bring that concentration down, you can reduce the ventilation rate. So getting a perceived air quality overall, I think it will be very, very challenging on that in terms of multi-pollutants. So you cannot replace, basically my view is you cannot use air cleaner to provide ventilation air.
Well, certainly you are absolutely right, but ventilation may not be effective for all the pollutants as well, and then we still use. So yes, the point is that the decision for the dimensioning of our standards is based on the perception of the air quality. It is the number of dissatisfied or satisfied people that need to, the level that needs to be achieved by certain ventilation requirement. And then if you can document that the air cleaner can provide a similar effect as ventilation, then you have a comparable thing. The point is that we will then have to evaluate whether, of course, it is across the board for the all pollutants, but at least for the pollutants that evoke the sensory perception and can be markers of long-term effects in the future, the effects should be similar, independently whether you use the air cleaner or you use the ventilation. Yeah.
No, the way you should look at it is, if you then have a pollutant source, exceptional source, which need a much higher ventilation that you calculate with the perceived, that's where you efficiently can put in the air cleaner when it's triggered at this pollution source.
So, yeah, are you suggesting that you can reduce the ventilation rate below the standard level? Yes. If really, okay.
Not below standard, ASHRAE standard, because they are too low.
Okay, the last final comment. It's a nice discussion, but you have to go on.
Of course, what Jensen is saying is also correct, because if you have an unusual types of pollutants in the space that you can handle by the specific air cleaner, you can use this air cleaner to handle those specific pollutants. Mm-hmm. For example, if you have pathogens in the space, you don't have to increase ventilation. You can remove the pathogens, for example, by filtration, or you can deactivate them by other means that air cleaner can provide. So you don't have to increase the general ventilation, but you still need to provide the level of ventilation that is prescribed in the standard.
Okay, thank you all. I'm looking forward to the results of all the annexes, so that, yeah, next year maybe. We have to move on to the next session, and it's about quality assurance of ventilation and heat recovery systems.